as we work through. All right, so before we had this part. A was our amplitude, how much everything got changed as far as, you know, the height of my graph. And then whatever value was in front of x is what we divided into 360 into our period to find our actual period of things. So now, ta-da, we add in the other two parts. Now, here's the one positive thing going for us. You've seen these shifts before. We did them on parabolas when we were working with quadratics. We did them on square roots when we worked on graphing square root functions. C and D listed here are the same things as we had before. The C value, my value in the parentheses with x, shifts our graph to the left or to the right. Okay, it's called a phase shift. If it's minus, it goes to the right, just like before. It's kind of the opposite of what you think. If it's x plus c, so like x plus 3, would shift our graph 3 to the left. Okay, so that becomes my left or right shift. And like I said, we're going to start with degrees, and then we'll roll that right into radians too. And then any value, and it also, just as a point of fact here, yeah, we're going to be shifting around. So you also could have it written this way where their D value is in the front. Okay? So no matter where that happens to be, if that D value is positive, greater than 0, the graph's going to move up. So like if I had something plus 4, my graph would move up 4. Okay? Not the same as amplitude. We're not stretching or shrinking it, but we're literally shifting it. We're literally moving it. And if D is negative, then we're going to go down that many. And at the start here, we're just going to work on looking at what are the shifts, what's the period, what's the amplitude, and all of that before we even start thinking about graphing. Okay? But that's the basic setup of these. So let me move this up a bit here because you've got reference to yours still. All right, so find the actions that are done to each. Now, not everything's going to change every time. It doesn't mean 4 things are changing every time. Is it possible? Yes. But it doesn't happen a lot. So for instance, in this first one, does my period change at all? Is there any value in front of theta? No. So what's my period? 360. And I thought I heard somebody speak pi here. So either one of those would be the same. Okay. Typically with these, again, if it starts in degrees, let's end in degrees, okay? If it starts in radians, we'll end in radians. And we'll kind of work it that way. Thank you. So, okay, amplitude. Do I have a coefficient in front of my sign? Not a special one, so my amplitude just is going to stay as 1. Okay, this first one's to show you that not everything's changing all the time. But what about a shift? Nice, okay. So this one would go right 60 degrees. If we were doing radians, it'd be right pi over 3. Okay. Here, I'll put that in here for my radian fans. Because again, remember, if you're like, wait, where'd that pi over 3 come from? Just remember that pi itself is 180 degrees. So if I wanted it 60, 180 divided by 3 is 60. So that's a quick way of getting my radian value without having to do the times pi over 180 trick. Okay? Now, second one, this is the one trick in this section. Bless you. The one trick we have. If you have a value in front of your theta, or they call it x or r or t or whatever it happens to be, you have to factor that out. In other words, when I get this into its form, theta has to be in the parentheses itself. So here's what this would look like. If I factor out the 3 comes outside. Okay, my theta is still there, because if I distribute, 3 times theta is 3 theta. 3 times what gets me to negative 45? 15. Okay. This would be the form that I'd actually use to graph, because now everything is where it belongs. Okay. Because you'll notice come up above here one last time. You'll notice now, different from last section, that my b, my number that changes the period, is now outside the parentheses. Okay? So if there's a number with this, or like I said, that x could also be theta, we're going to pull it out so it's in this form, and that'll be the number that I'm dividing into my period. So when I come back down to example 2,
I don't know if this question is stupid or not, but can it be like the amplitude can be different numbers? Like if there was like a 2 and a -2, it could be like 2 and a -3. No?
nope. Amplitude will always be the same going both directions. Here, since we're in degrees, my period normally be 360, but I've got to divide by my b value. So it's 120 degrees. Okay, if we were dealing with pi here, we'd take 2 pi and divide it by 3. It would be 2 pi over 3. And I'll keep putting those in on these just so you've got the reference to work with. Because again, 2 times pi would be 2 times 180, would be 360, divided by 3. So we'll play with both of those sooner or later, but you don't have to do them both on every problem. Do I have a change in my amplitude? Is there a number in front of cosine? No. Okay, that stays the same. The only time my amplitude is going to change is if there's a number in front of sine or cosine on this. Okay, what about a shift this time? Okay, right, 15 degrees. So you kind of start to see, you're like, okay, so the only thing that's really changing here is if I'm seeing these extra pluses or minuses, they're going to mess with my shift a little. If they're inside the parentheses, we're playing right or left, but, ooh, we get both of them in example 3. Any change to my period in example 3? No, because there's no number here with my theta. There's no number in here that tells me there's going to be one. So that'd be 360. Is there any coefficient in front of cosine which would change my amplitude? Not a coefficient though, but right, there's a number there, but not a coefficient. You're like, Hardy, you're never changing the amplitude. It's coming. Now, shift. This time there's 2. Left 30 degrees, good. And up 5. So some of you are starting to think already, okay, how big are some of these charts going to get? They're still not going to get bigger than 3 columns, and that's just to get used to it. So don't panic. That's why we're doing this, to have a reference. I did make a boo-boo on example 4. I will admit it right now. I have to fix this. I'm going to cross this out and rewrite it. Well, there's actually one major thing wrong with it. Uh-huh. This was supposed to be 2 pi, not pi over 2. That's going to change a lot of things. That's going to make life much easier here. So you're like, okay, ooh, you said before theta's got to be by itself, but it's over 3 right now. So if I went to rewrite this, and I have to, because I have to factor the 1/3 out, because again, if it's over 3, it's not like it's 3 pi, where I can just put 3 theta, where I could just put the 3 out here. That fraction's making it 1/3, and now I got to think for a minute. 1/3 times what, ooh, gets me to 2. In other words, what divided by 3 gets me to 2? 6. Some of you are like, wait, what? Multiplying by 1/3 is the same as dividing by 3. So when I distribute this, 1/3 theta, okay, 1/3 times 6 is 2. And then my minus 3 stays the same. So you're like, wow, that's a big old mess of stuff. So now, everything's in radians. Here's kind of our final exam on this. Okay, what's my period normally in radian or in pi mode? 2 pi. So 2 pi divided by 1/3. What's dividing by third the same as multiplying wise? Multiplying by 3. So my period would be 6 pi. Do I still have any amplitude change? No, there's still no number in front of my sign. Now, shifts this time, we have 2 of them. Okay, down 3. Okay, down 3 because of the -3 here on the end. And left 6 pi. This is the type of, and this again, this is the extreme, okay? Example 4 is the extreme case. Most of the time it'll be more like 1 through 3, where you may have a period change and a shift, you may have 2 shifts, but it's not going to be every blipping thing possible that's moving around on you. But if it does, we're going to work at it one piece at a time, okay? So when we get into the graphing part of this, there's going to be very little that's different from what we've been doing for the last 2 days. So when we actually get to that part, and we're just going to play with degrees today, we're not going to play with radians until tomorrow. So graph the function using degrees, okay? First thing is always, we're going to look to see if there's an amplitude change, a period change, a shift, whatever it happens to be. So here, okay, my period's not changing. So it's 360 still. That's all fine and good. What's my one shift going to be? Okay, we're going to go left 45. So, normally, with one of these, when I'm working in degrees, and it's kind of interesting. I hadn't thought about it this way before when I was trying to remember the numbers and things, but Kevin actually had mentioned this when he was in earlier, and I'm like, you know, that's a good idea. When we're looking at these trying to figure out quarter points, especially if it's not the regular ones, because you're like, yeah, I remember, you know, 180's in the middle here, because it's like a halfway point. It's almost like an average. When you're looking for quarter points, just keep finding that middle ground. Directly between 0 and 180, 90's halfway. Directly between 360 and 180, 270's halfway. Okay? That's going to be an easier way for some of you to remember, now what goes in here I don't remember than some of the other ones do. That was if I didn't have any shifts. We're going to get to radians, but right now we're just going to keep it simple with degrees and then grow to radians. So here, my shift is going to be my degrees minus 45. You're like, why minus? Because when you move left on a number line, what are you doing? You're reducing the value. It's going negative. So what I'm going to do is I'm going to subtract 45 from each one of my degree values, and that becomes the degree measure that I'll use when I'm graphing. Now, I didn't change my period at all. I didn't have an amplitude change. So what are my values going to be? When we start at sine, we start at 0, 1, 0, negative 1, 0. And once I get that set, I'll kind of wipe out the old degree measures so I'm not tempted. I'm like, well, what one do I use? These two. Thank you. So, you're like, well, how does this work? I mean, we have negative degrees. We haven't done that before. And we have all these numbers. I don't see those numbers here. They're all by 90s. Well, remember, when you're doing these, there's a line in between, which would be the halfway point. So, this first one's actually 45. 1, 0, We'll zoom in a little more here. This one between 90 and 180 would be 135. Between 180 and 270 is 225. And so on. So that's the nice thing about making your own graph. Once you've done this, you don't have to worry about this, what we're doing right now. You can just make it, you know, your own degree measures. The other nice thing is there's one line before my 0, which would also be my negative 45. How convenient. So once I get that, negative 45 puts me at 0. 45 puts me up at 1. 135 is back to 0. 225 is back to negative 1. And 315 is back to 0. And similarly to what we did yesterday when we were graphing, if I was either asked to go more than one period or I wanted to, just keep the pattern going. So it's every 90 degrees, so I'd skip again and go back up to 1. Back down, and I'll show that with the red just so you see that's what I additionally could do if I was asked for more than a single period. But that's the route I'd go right now. Now some of you, again, might be able to look at this right off the bat, remember these, and just subtract 45 from each and go, and that's fine. But otherwise, again, take a moment and kind of work your way through it that way. Shift a little to the right here. What's my shift in number 2? Okay, right 90. Okay, my period's still the same. Hasn't changed. So, I'm going to shift over here a little bit. So let's see if we can do it this time and just go for it. Let's see here. So the degree, I'm going to be adding 90 because I'm going to the right. Okay. My values aren't going to change. So my values are going to be the typical base for cosine, which is 1, 0, negative 1, 0, 1. But when I go to do my degrees, I think of my base degrees, but I'm going to add 90 to each of them. So 90, 90 plus 90 is 180. 180 plus 90, you're like, oh, you're just basically taking all these numbers and shifting them right. And some of you may, yep. And some of you may be looking and going, well, but wait a minute, when we did this before, whatever my period was always ended up being the last number. But remember, we're now moving left and right, so we're moving that period with us. It's still 360 degrees, it's still a full period, but it may not just start at 0 and end at your period once we get the shifts going. So once we get that set, I can just plot my points. And again, if I wanted to, I could easily tell where my next points were going, and I could just continue that right through the end. Just follow the pattern some more. But again, take it in small pieces. Don't try to take big, huge gulps of everything, and then when it goes haywire on you, go, oh my gosh. Go this route if you have to. Go with a chart, okay? Now, let's kick it up a little. Just a little. So if I move up here, up to the side, let's go for number 3 here. See what's happening. Okay, this time, I've got a number in front of my theta. That's got to be factored out. So we're going to take that 2 out, and it goes after cosine. Theta minus what? 60. Because 2 times negative 60 would get me negative 120. They still should be equivalent, just looking at them a little differently. So now this time I notice a couple of things. What's that 2 going to do to my period? Cut it in half. So 360 over 2, okay, it's 180 degrees. It would be pi. Yep.
And so 2 pi over 2 equals?
would be just pi. So, right, my period here would be pi if I was in radian mode. What's my shift going to be?
Right 60.
Okay, shift is going to be right 60. So you're like, ooh, there's all sorts of stuff going on here. And there is. So let's see here. Yeah, I'm thinking we're going to go to an extra column this time. Okay, first things first. When I make my regular degree column, remember, my period is 180. Okay, I'm not worrying about the shift yet. If my period's 180, without the shifts, I think, okay, I need quarter points. 90's in the middle. What's in the middle of 0 and 90? 45. And in the middle of 90 and 180? 135. And again, if you're not sure, just find the average. Just do 180 plus 90 divided by 2. Okay? So that's my typical degree. But now I want my degree measure. I moved right 60. So I need to add 60 to all of them. So I got...
How do you know that you have to start with 45, 90?
Because what I'm basically doing here is, if you think about your prototypical, okay, if I was starting with my regular degree measures here, yeah, if I was starting with these.
Since you cut it in half, that's why.
Exactly. Yep, we're just cutting those in half. So then now once I have those, I'm just going to add 60 to each of them. Those will be the angle measures that I'm using. But since I didn't have a change in my amplitude, my values won't change from a typical cosine value. 1, 0, -1, 0, 1. And again, I don't need those initial ones anymore because I want to graph what I see here. So you're like, okay, well 60, I see 60. Well, what's up with 105? Now, 105, because the line here would actually be 90, 105 is going to be kind of the midpoint. So we're going to run into these little midpoints here that we're trying to find our values, because 105 being at 0 is right here between the 90 and 120. Again, another benefit for drawing your own instead of having pre-made graphs. 150, okay, there's actually a spot for that here, right in the middle. 195 is going to split these two. And 240 gets me back to 1. And again, if you just want to draw your specific period, that's fine. Okay, not a big deal. If you wanted to keep going, you could easily see the pattern and just kind of keep going about your business. So you're like, all right, this might not be too bad, maybe. I don't know.
Can I ask why we have to have a problem? Okay, no.
Because when you're doing this, if that's in there with it, now when you're going to look at it this, let me get back to the original equation here. If you have it inside with this, now that would change your actual shift, because if you think about it, the shift is whatever this minus c is. And if I don't just have x there, like if for instance on 3 that we just did, if I have 2x, you're actually doubling what that move is going to be. So it's one of those, if you can mentally just think about that, I don't suppose you would have to rewrite it. You could look at it and say, okay, that 2 there means this is going to get cut in half. And that's just 60, but a lot of people tend to forget about that, and then they shift it right 120. Yep, and that just becomes more of an issue. So, let me move down to 6. Let's try out a different one here. So, if I get to 6, all right, let's see what changes here. Am I going to have a period change this time?
Yeah. No.
Is there a value in front of theta? No. Okay, so my period is still going to be just 360. Okay, But what am I looking at shift-wise? Okay, right 45 and down 2. Okay, here's the new one. So you're like, all right, we got this. When I look at my degrees, remember what your typical degree set is when you're working with 360. 0, 90, 180, 270, 360. You want to add 45 to that. So if you need to, this is something I catch myself doing a lot. I'll make myself just a little mini reminder of what my values are. And then when I go, I'm like, okay, so 0 plus 45, 90 plus 45. And just basically keep adding 90 once I get that first value in there. My period's still 360. It's still 405 minus 45.
Why is it negative when we add it to the right?
Because the actual format is going to be like theta or x minus the value. So the actual value that you're subtracting here would be positive 45, which is why I'm going right. Because then when it's plus, it's like it's minus a negative, is what I'm basically doing there. So once I've got my degrees, then I can start doing all of this other fun stuff. So normally, my values, if I didn't have this extra downshift, using cosine would be 1, 0, negative 1, 0, 1. But I'm going down 2, so I'm going to subtract 2 from that value. So 1 minus 2 is negative 1. 0 minus 2 is negative 2. Negative 1 minus 2 is negative 3. And then back to 0. 1 minus 2 gets me back here. So once I have that, I don't need these. And that would have been one I probably could have just made myself a little note so I didn't need the third column. But again, it's going to become a preference. Now this time, remember, 45, 135, it's going to be my, my lines in between. So at 45, I'm at negative 1. At 135, which is right here between 0 and 180, I'm at negative 2. At 225, I'm at negative 3. 315's back to negative 2. 405 is back to negative 1. So a lot of similarities to yesterday, except sometimes your value might change a little, sometimes your degree that you're starting with might change a little. We're going to hold off and wait on radians until tomorrow. So here's what you can do right now. They're like, oh, here's what we can do. Oh, geez. Yes, actually, oh, I've got it stacked over here. We can absolutely get some more graph paper rolling. So here's what we are going to try for, whoops, it'd probably help if I was on the screen, wouldn't it? All right, we are right now capable. I'm going to make a tweak to 10. I'll be back to that in a minute. That's the one we're going to be graphing. On the others, oh, here's my easier way of doing it. I have it written out already. Okay. So on 844, number 10 right now is written in radian form, but I want you to get practice with one of these, just doing it in degrees like we did, so I changed it. So the problem you're actually doing is y equals 3 times the sine of x plus 180, because in the book it says x plus pi. So that's the one graph I want you to do to kind of get a little bit of play with this. And then that next group of numbers, 17, 19, 20, 21, 22, 25, you're just going to look at the equation and tell me what the shifts are. So just basically like what we were doing up here. No graphing in 17, 19, 20, 21, 22, 25. Just shifts. Tomorrow, We will do this in radians and get practice, and we will do more graphing tomorrow.
You just want to see the shifts, or you want to see the amplitude and periods? And
If anything that changes in there, I want to know about it.